I'm here at Tremo Barton Field. It's a lovely place and hopefully soon to be the site of a new sustainable development. Now, when it comes to meeting our climate goals, one of the ways in which we can do so is by becoming more energy efficient. Simply put, we all need to use less energy. So one of the things we wanted from our design was to get the occupants thinking about their energy consumption and sustainable living. Let's take a look at the building and some of its features.
Here is the design we created. I'm sure the first thing you see is that it's one floor. Now, this may be perfect for may not be perfect for the passive house ideals. However, we did not want to compromise on anything coming into the design process. We wanted to create a sustainably built passive house that was not only given a great living experience, but also an education. We chose the bungalow as to not affect the sense of vernacular too much. There are great views all around Cornwall. We didn't want to ruin that. For those that do look at it from afar, we ensured we didn't compromise on looks on the exterior, hence the wooden cladding on the outside of the building. To enable the residents to make the most of the views available, we also made use of large south-facing side of the house by putting floor-to-ceiling windows in. This allows a modern feel to the house and without losing performance thanks to the triple glazing. The brise soleil in the indentation of the house is to help cool the house in the blazing heat of the summer, as the windows will give large solar gains, so it forms one of the mitigations for this. The large amounts of solar comprising of both solar PV and solar thermal not only creates a large energy offset, but will also give the resident a challenge. There is enough solar to power the house in its entirety if the residents use the house as efficiently as possible, forming another aspect of that education I mentioned earlier. The green roof helps with the vernacular of the building, but also provides an excellent place to allow for rainwater collection with over 100 metre squares, thanks to the bungalow design. This allows the collection of more than enough water for the toilets and washing machine. When creating the floor plan, the same principle of no compromises was key again. We wanted to ensure more than comfortable living for our residents, creating luxurious bedrooms, living spaces and kitchens. Another key aspect was making the building for life. This meant spare bedrooms were incorporated into our design, meaning that should the resident require any special rooms or spare bedrooms, etc., the house would facilitate so. For a passive house, volume and surface areas of the building are vital. To ensure the best outcome possible, the heating envelope does not include the garage or workshop, as these rooms are not required to have the same level of heating or cooling.
The compost toilet, whilst not part of the main structure, is a simple and cost-effective means of dealing with excreta without the means for water. This could be more relevant in the coming years as summers are anticipated to become hotter and drier as a result of climate change. Based on a 10-year service life, the toilet would pay for itself within the first 5 years and save the occupants £235 in water rates. The features are a passive ventilation system which uses an aerofoil type ceiling to draw air up and out of the chamber, whereas the chamber itself is draft free. This prevents a rise of odour. The urine separator is crucial for decomposition, and the urine is diverted either for collection to be used as a fertiliser or straight away down into the soakaway. The excreta, meanwhile, falls through the fly trap into one of the two decomposting pots, where it decomposes over the course of the year. The two pots mean that they can be rotated and one can decompose without any fresh additions. The toilet also features a rainwater harvest, which we can use for hand washing.
So the compact service unit is essentially an integration of different renewable energy technologies. So the MVHR, which is the mechanical ventilation heat recovery unit, is combined with an air source heat pump, which means that all the space heating demand is met. Any excess energy produced by the combination of the two is then combined with the solar thermal, which is placed on the roof to heat a buffer tank, which provides all the daily hot water demand for the house. So overall, this reduces a reliance on grid and ensures passive house standard ventilation. So how the NVHR itself works is, through a carefully planned duct layout throughout the house, it takes humid extract air from the kitchen and bathrooms and is then passed through a heat exchanger and air source heat pump, which then heats clean, cool incoming air from outside and supplies it throughout the house. This is to ensure constant air quality and space heating. As previously mentioned, the remaining energy will then heat a 200-litre buffer tank, which is aided by a solar thermal panel located on the rooftop. So both the NVHR and integrated air source heat can be placed in the utility room, which maximizes spatial efficiency. The choice of the NVHR has been chosen is very specific. It's highly efficient and has an efficiency of 88%, which is greater than the 75% passive house standard. There is also low noise at 35 decibels, which would prevent any occupant discomfort through loud noises, which normally occur with less efficient NVHRs. There is also very low leakage rates, both internal and external.
Here at the Passive House Performance Group, we all come from a background of renewable energy. We all studied it at the University of Exeter, and we have now formed this architectural group with a passion for renewable energy. This is why we've put so much of it into our passive house. The power of the sun is the most sustainable source of energy available on the planet, and all renewable energy stems from it. Sun tunnels are an effective and zero carbon source of lighting, and the large self-facing windows maximize the solar gains. This is also a totally renewable and zero carbon form of heating. Air source heat pump, as already mentioned, is more energy efficient than an electric boiler, and 60% of the annual hot water demand will come from our evacuated tube solar thermal panels. These are also very low carbon and excellent for the environment. We've got an extensive array of solar panels on the roof, solar PV panels. These are coupled with a lithium-ion Tesla battery, which will provide a large proportion of the household demand. This solar photovoltaic system increases the sustainability of other features that use electricity, such as the rainwater pump, the air source heat pump, and the LED lights. The design output summary of the panels is a 5.7 kilowatt peak with a yearly output of 6.59 megawatt hours. Has an upfront capital cost of £14,600, including the battery, therefore providing a levelized cost of energy of 8 pence per kilowatt hour. Equipment was chosen because of the long lifespan and guarantee on them, and the payback period of 10.6 years is reasonable. Yeah, the 16 LG 355 watt silicon mono panels are top of the range panels with an efficiency of 20.6%. Power optimizers fitted to the back of every panel increase output by constantly tracking the maximum power point of each module. The Tesla Powerwall battery is the bee's knees of domestic lithium-ion batteries. A massive 13.5 kilowatt-hour storage capacity, high round-trip efficiency of 93%, and low annual degradation are far superior to anything else available on the market. The Powerwall lets us use the power of the sun at night. This results in less solar power sold to the grid and more used in the home. This is better economically and sustainably.
Our final feature that we're most proud of is the rainwater harvesting system. So once all the debris has been filtered out, rainwater is suitable for use in both flushing toilets and feeding washing machines. And this system uses the unoccupied roof space, which totals to 101 meters squared, to capture the rainwater and channel it into a storage tank. The tank is underground to prevent solar radiation from evaporating the water and to keep the views from the house unobscured. If we look inside the rainwater tank, we see that there's a pump which is pressure sensitive, meaning that water can be supplied to the toilets and washing machine at a high enough pressure. And the pump only switches on when there's demand for water, which saves electricity. Also included in the tank is a filter which self-cleans every once in a while, and this ensures easy maintenance.
One compromise for our budget was the precast concrete block foundation. The main objective, of course, for the foundation was sustainability. However, after substantial research, we found that sustainable options were massively outside our budget. So we compromised and used precast concrete slabs. Precast is 40% less carbon intensive than pouring it out on site, and it saves 40% on labour as well. The timber cladding exterior, whilst also cheap, was believed to be the most attractive and most sustainable option. It wasn't a critical focus to the building, as the hard frame was also used. So aesthetics was the main desire there. We considered options such as brick or painted wood, but these would have increased the costs further. A passive house refers to a comfortable and healthy home whose energy demands, especially for heating and cooling, are exceptionally low. The table shows that the design achieved the passive house standard of building. The cooling demand being higher than the heating demand does not come as a surprise due to the thick insulation with over 200 mils of sheep's wool. The heat generated in each room, whether that's from hot showers, cooking, solar gain, etc., means alongside the insulation there's no large heat losses. The heat is instead extracted by the mechanical ventilation heat recovery unit and spread to the colder areas to keep the house at an equilibrium temperature. Furthermore, the table demonstrates the primary energy demand is offset by the solar PV and solar thermal on the roof, as previously discussed, so much so that it's unlikely you would need to use much electricity from the grid at all. For example, if the hot water is stored in a tank and being topped up if needed by the heat pump within the heat recovery system. One cause of concern was raised while undertaking the required passive house calculations. Due to the large south-facing windows, the solar gain in the summer is very large, which could lead to overheating. The introduction of the brise soleil helps cool the kitchen, diner, and living room without compromising on the overall aesthetic. All windows are able to open, including the four large south-facing windows. And additionally, there's a cooling function in the heat recovery system, and of course, all alongside traditional methods such as blinds and curtains. I think it's clear from the above information that this house would be beyond comfortable to live in and also comfortably meets the passive house requirements.
One definition of sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So when we think about the building and the current climate situation, certainly would need to be towards carbon neutral or carbon negative. And as for the materials, they need to be sustainable and replenished within a practical time frame. Wherever possible, sustainable materials have been selected. For example, the timber frame, which is locally and sustainably sourced. This ensures that the materials can be replenished on a practical time frame with minimum carbon intensity. The timber frame also acts to fix carbon and keeps it out of the atmosphere. The sheep's wool insulation and the recycled concrete floor reduces carbon intensity following the waste management hierarchy. The renewable energy systems installed will abate over 2,000 kilograms of CO2 per year against current grid intensity. Whilst the building isn't carbon neutral, it's very close. In fact, the emissions are so low that they could easily be offset elsewhere on site, perhaps through the planting of trees. Some of the sustainable features include encouraging recycling through strategic placement of the bins. This encourages the occupants to recycle as opposed to throwing things away. We also give the occupants the option to use the compost toilet. This will save on water and associated energy with processing the waste. We're also recycling rainwater for the flushing of the toilets and washing machines. Some of the sustainable features also include smart metering, which can be used alongside the Tesla Power app. This allows occupants to track their energy and can help them balance power drawn from the grid. Smart appliance can be programmed to switch on where there's plenty of solar energy or at times of low demand. Automatic lights will prevent lights from being left on, thus wasting energy.
Requirements for the specific aspects of building design and construction will be submitted for approval to the local authority. Structure. The timber frame structure and design will be assessed by a structural engineer. The main point of concern is the weight of the green roof. I've included a strength properties for timber frame, which should be submitted with the documentation to the local authority. Part B, fire safety. Here is the floor plan of our house. The fire escapes are shown by the green pluses. These are openable windows or doors that can be used as an escape if there's a fire. The fire alarms are placed strategically to measure carbon monoxide and carbon dioxide levels and are state of the art. Firefighting equipment should be installed in the kitchen and the workshop. Finally, fire doors throughout the house are placed for compartmentation and isolation to prevent fire spread. Part C, site preparation and resistance to contaminants and water. So there are plans to execute a full radon inspection of the grounds before any foundations are dug. A watertight membrane used on the outside of the frame will keep the insulation watertight, and the wood cladding will resist weathering, and the rain will not cause damage to the roof because of our rainwater harvest. Part D, toxic substances. Often insulation used can be toxic. We have gone for natural sheep's walls. Part E, resistance to the passage of sound. Our mechanical heat ventilation heat recovery system has been sound dampened, and the house has been moved further away from the main road to reduce the noise. Part F, ventilation. We want our house to be as comfortable as possible, so we have incorporated a ventilation system to ensure fresh air for comfort. The heat exchanger will ensure that heat is not lost despite this fresh air coming in. Passive House criteria states you must not leak more than 60% of your volume per hour. We have calculated our minimum air change rate to be 43.25 litres per second, and the ducting layout is shown here. So finally, some noteworthy points that come under other regulations. We will definitely pass all of the energy efficiency demands of the building regulations because we're passive house. That goes above and beyond. Our house has full disabled access and high-speed fibre optic Wi-Fi. The budget for the building was actually £1,800 per metre squared, with a cost to the finished build of £364,400. This gives us a cost metre squared of £1,610, which I feel is quite reasonable for a house with such energy efficiency and sustainability.
BREEAM's home quality mark is an integration of aspects from both the sustainable and passive house approach to building design, which we have opted for, in terms of occupant comfort and choice of materials. So it effectively summarises how well our design fulfills these goals and its overall build quality. So the home quality mark criteria consists of 11 categories, which cover sustainability, energy usage and occupant comfort, of which our design satisfies many, thus indicating a high build quality. So some of the key categories are safety and resilience, which is fulfilled through the rainwater usage, which serves the purpose of reducing the demand from the mains water, while it also acts as a flood risk mitigation, thus providing safety. Thermal occupant comfort is at the forefront of our design alongside sustainability. So adequate ventilation is provided through the combination of passive and active methods through the use of Brise Soleil and MVHR respectively. So for energy efficiency, we used low carbon technologies. So that's so the energy efficiency throughout the house is kept up through the use of sustainable insulation materials which prevent energy losses, while also then highly efficient renewable energy systems have been incorporated into the building's design. For example, the MVHR has an efficiency of 88%, way above the 75% recommended by the Passive House Standard. And in terms of materials, obviously, as previously mentioned, we've used highly efficient materials throughout that are all sustainably sourced. For waste, we use water recycling systems using rainwater for flushing and washing, while then compost bins have been placed throughout the property to ensure occupants use them for household waste. So overall, the building's design matches the three fundamentals of the home quality mark, which have been listed there: my cost, my well-being, and my footprint. Thus, we've achieved a cost-efficient, low-carbon footprint home that ensures occupant well-being.
So there you have it, a highly efficient and low-carbon home. Finally, the building and all of its systems must be underpinned by a simple yet concise set of instructions so that the occupants can use the building as intended, that way mitigating the effects of the Jevons paradox.